Hello everyone, this is Rina. In this video, we'll be talking about the idea of injections, surjections, and bijections. But before that, we need to go through first the concept of a function to fully understand them. We have been so familiar with the word function, and I'm pretty sure that we encountered that in our math subject. The literal meaning of a word function is to relate an input to an output, or to relate a domain to its codomain. Suppose that the domain and the codomain is a set. The domain will be the set A and the codomain will be the set B. And we already know that in a set, there are different kind of elements within it. And in here, for every element X in set A, there is a Fx in set B. The resulting Fx is what we called the range of the codomain. With those ideas, we will get the function or the rule of a function f such that A implies to B. This means that where for all A in set A, it associates an element of function of x in set B. So we already know the idea of a function. So the injections, surjections, and bijections tell us how a function behaves, or how the function relates the inputs to its outputs, or the domain to its codomain. Injections, or one-on-one function. Let f such that A implies to B be a function from the set A to set B. The function f is called an injective provided for all x1 and x2 is in set A. If x1 is not equal to x2, then the f of x1 is also not equal to the f of x2. We can also write this in the form of x1 and x2 is in set A. If x1 is equals to x2, then f of x1 is equals to the f of x2. Notice that the condition that satisfies this idea of injections is written in a conditional statement. A conditional statement have a connectivity of f and then. And you can see in here that it uses the f and then. A function will not become an injection only if there exists an x1 and x2 in set A such that x1 is not equal to x2 and f of x1 is equals to f of x2. Notice here that it contradicts the idea of the injections. In here, the idea is not written in a conditional statement. This did not written in the f and then connectivity. And also, the x1 here is not equal to the x2, while in the idea of injection, the x1 is equals to the x2. Note that we must remember a function f such that A implies to B is only become an injection if and only if for each fx in B there is at most x in A. For example, we have this illustration of a set A and set B, where the set A is the domain and the set B is the codomain. And we notice here that A is consists of the element A, B, C, and D, and set B is consists of the element of V, W, X, Y, and Z. The most common or obvious difference between the two is that set B has much more cardinality than the set A. And the second one is that each element of the set A has its own range in the set B. This is what we call one-to-one because element A or the domain only have one range in its codomain. So 1-to-1. Surjection, or known as one-to-one function. This function let the f such that A implies to B be a function from the set A to the set B. The function f is called a surjection, provided that the range of f is equal to the codomain of f. This means that for every y in set B, there exists an x in set A such that f of x is equals to y. A function will only not become a surjection if there exists a y in set B such that for all x in element A, f of x is not equal to y. In here, we can obviously see that the there exists sign is in set B. If that happen, the function is surely not a surjection. If f is a surjection, we can say that the f is an one-to-one function, or f map A onto B. Note that we must remember f such that A implies to B is a surjection f and only if for each f of x in B there is at least one x in A. For example, in this illustration, we also have this set A and B where set A is the domain and set B is the codomain. And we can see here that the A has its one range in codomain B. So we can conclude that this example is a surjection or one-to-one function because the element in set A has only one set B. Bijection. or also known as one-to-one and on-to-one function. This is the function that is both an injection and a surjection. If a function f is a bijection, that means that the function is also an one-to-one and on-to-one function. Important notes we must remember for bijection. Function f such that A implies to B is a bijection if and only if for each f of x in B there is exactly one x in A. We have this example. As we can see in this illustration, we also have the two sets, set A and set B, where set A is the domain and the set B is the codomain. As we can see in here, there are one exactly arrow which indicate that the element A has exactly one range. If we compare this to the surjection and the injection, in injection there are more cardinality in the codomain, while in the surjection there are more cardinality in the domain. In here we can see that they have the same cardinality. And that's the end of this video. Thank you for watching.